Going back to last week, you mentioned this gut peptide called cholecystokinin. Was previously shown to have a crucial role in mediating the effects of intragastric fatty acid solutions on brain activity. And they were saying that the receptors for CCK, this cholecystokinin, are known not only for their role in digestion, but also for roles in memory function and learning, and in the modulation of panic and anxiety. So there's this link between the gut and the emotion. So it's not gut is not just for digestion and picking up food and sending it off to the various departments that store it, like the fat cells, etc. But it also triggers emotive events in people. What do you interpret from my suggestion that CK's role in the stimulation and secretion of bile and the digestion and the absorption of nutrients, especially fats, supports the link between this mental function and digestion?
I think it's good to consider at least one other digestive peptide, the gastric inhibitory polypeptide, GIP.
Okay.
It's my general picture of the organism, for example, analogous to the sympathetic nervous system and the parasympathetic nervous system.
Right.
The day and the night sides of the nervous system.
Right.
Everywhere you look, you can see this sort of a polar opposition in two kinds of function. One is mobilizing, the other is demobilizing and relaxing.
Okay, that's the parasympathetics is the relaxing, and the mobilizing is the sympathetic.
And when the organism is young and healthy, that opposition works very nicely for night and day action and rest cycling. And in the digestive system, when you eat fats and proteins, you secrete the cholecystokinin. When you eat sugar, you secrete the GIP, which is also called the insulinotropic hormone, because it calms down, stops your acid digestion, because you don't need acid to handle sugar, but it activates the insulin so that you handle the sugar. And when you look at the effect in the brain, CCK activates the corticotropic release hormone, which turns on anxiety and stress, and the pituitary ACTH, which turns on the adrenals to handle stress.
Okay.
And the gastrointestinal gastric inhibitory peptide responding to glucose has pretty much the opposite effects. And in the hippocampus, for example, which is a part of the brain that's expanded by opportunity and learning, and shrunken by stress, the insulinotropic hormone responding to sugar also has receptors in the hippocampus that stimulates the birth of new cells. So learning and stimulating experience and eating sugar has the same
go hand in hand, huh?
Yeah, the same effects in your brain. Eating fat and protein, surprisingly, turn on anxiety and stress.
Even protein, huh?
Well, that tends to lower your blood sugar because it also stimulates insulin.
Got it.
And lowering the blood sugar turns on stress.
Okay.